Elon Musk sends shockwaves through the cosmos as he unveils a recent jaw-dropping discovery about our neighboring planet, Venus. Despite its eerily similar size to Earth, with a radius of 6,052 kilometers compared to Earth's 6,371 kilometers, Venus is the evil twin with a hellish atmosphere in stark contrast to our life-friendly environment. What's hidden on this evil planet? Venus, often hailed as Earth's cosmic sibling due to its comparable size and composition, harbors a tapestry of differences that captivate the imagination. Foremost among these distinctions is Venus's claim to being the solar system's hottest abode, boasting surface temperatures that could rival the fervor of a blazing 864 degrees Fahrenheit, a veritable crucible that could melt lead. Adding a twist to the celestial dance, Venus revolves in the opposite direction to the majority of its planetary counterparts, leading to a captivating cosmic paradox. This peculiar rotation results in a day on Venus outstretching its year. Why Venus, despite its greater distance from the Sun compared to Mercury, the solar system's fiery furnace, exudes such searing heat? The answer lies in the veiled secrets of Venus's thick atmosphere, predominantly composed of carbon dioxide. This atmospheric blanket gives rise to a greenhouse effect, trapping heat and propelling Venus's surface temperature into the extremes. In 1962, NASA's Mariner 2 embarked on the first successful interplanetary mission, skimming past Venus at a distance of 22,000 miles. Armed with cutting-edge instruments, it unveiled the mysteries of Venus's atmospheric conditions. Meanwhile, the Soviet Union's Venera series, spanning from 1961 to 1984, orchestrated a series of probes that dared to descend to Venus's surface. Amid initial failures, Venera 7 triumphed in 1970, transmitting data from the surface of another world for the first time. Subsequent missions, including Venera 9 and 10, captured images and samples, shedding light on the enigmatic composition of Venus's surface. In this cosmic ballet, exploration becomes a dance of discovery, revealing the intricate steps of a planetary partner we are only beginning to understand. NASA's Pioneer Venus mission unfurled its wings in 1978, delivering not just an orbiter, but a squadron of 4 atmospheric probes. These intrepid probes delved into the intricacies of Venus, measuring its atmospheric composition, temperature, and pressure. Simultaneously, the orbiter embarked on a celestial cartography mission, mapping the enigmatic surface and scrutinizing the planet's magnetic field. Following this celestial overture, NASA's Magellan mission took center stage in 1989, orchestrating a symphony of radar technology to unveil the secrets of Venus's topography. The mission provided a meticulous portrait of the planet's surface, revealing mountains, valleys, and craters in exquisite detail. Magellan's resonant notes echoed further, divulging insights into Venus's volcanic activity, unearthing over 1,000 volcanoes dotting the planetary canvas. In the interstellar ballet, the European Space Agency took its turn, launching the Venus Express in 2005. This celestial envoy gracefully orbited Venus for over 8 years, immersing itself in the study of the planet's atmosphere, temperature, and ionosphere. Among its celestial discoveries was a cold collar in Venus's upper atmosphere, contributing to our understanding of the planet's distinctive atmospheric tapestry. The cosmic narrative continued with Akatsuki, the emissary of the Japanese Aerospace Exploration Agency, making its celestial debut in 2010. Despite an initial misstep in 2010, Akatsuki gracefully recovered, entering Venusian orbit in 2015. Since then, it has been a vigilant sentinel, peering into the planet's atmosphere and deciphering its intricate weather patterns. Venus continues to tantalize our curiosity, and recent revelations have injected a fresh surge of excitement into our exploration of this mysterious planet. Elon Musk's SpaceX team, as mentioned earlier, has unearthed evidence of phosphine gas permeating Venus's atmosphere, raising the tantalizing prospect of microbial life. This groundbreaking discovery has reignited our fascination with the possibility of life beyond Earth, prompting scientists to chart new missions aimed at delving deeper into Venus's secrets. In the Venusian clouds, scientists have discerned an anomalous abundance of phosphine molecules. On Earth, this stinky and flammable chemical is synonymous with feces, farts, and microbial activity, a telltale signature of life. However, Venus presents a stark contrast, with its hellish landscape boasting sulfuric acid clouds, oppressive surface pressures, and temperatures capable of melting lead. The revelation of phosphine in a relatively temperate cloud layer is nothing short of extraordinary. This layer, bathed in ample sunlight and possessing Earth-like atmospheric pressure and temperature, emerges as a potential crucible for supporting life as we conceive it. How did we figure out that there's phosphine on Venus, and what does it have to do with the cosmic dance of celestial brilliance? Venus, after the Sun and Moon, stands as the brightest object visible to the naked eye in Earth's sky. Jane Greaves, a radio astronomer at Cardiff University, directed her gaze toward this glittering jewel in 2017. Using the James Clerk Maxwell telescope on Mauna Kea in Hawaii, she sought barcode-like patterns of light in the planet's spectrum, a cosmic fingerprint revealing the presence of various chemicals. Amidst her analysis, she detected a distinctive line associated with phosphine, an unexpected finding given the harsh conditions prevailing on Venus. This stinky and flammable chemical, typically linked to living organisms, hints at the possibility of microbial life lurking within Venus's clouds, an astonishing proposition that could reshape our understanding of our celestial neighbor. While further research and analysis are imperative to validate this groundbreaking discovery, the implications are profound and could redefine our cosmic narrative. Phosphine, infamous for its unpleasant odor reminiscent of garlic or rotting fish, carries with it an intriguing history. Clara Sousa Silva, a molecular astrophysicist at the Massachusetts Institute of Technology and a co-author of the study reporting the phosphine finding, delves into the complexity of its formation.
It's my job to find aliens, so as you might guess, I spent a lot of time thinking about them.
The aversion between phosphorus and hydrogen, their affinity for other elements, and the rare circumstances under which phosphine is produced contribute to the mystique surrounding this intriguing chemical. Gas giants like Jupiter and Saturn, with their hot interiors, naturally harbor phosphine. Undeterred by the mysteries of Venus, researchers conducted follow-up observations with the potent Atacama Large Millimeter-Submillimeter Array in Chile last year. Once again, the atmospheric signature of phosphine resonated in their data. Exhaustively exploring every conceivable explanation, from volcanic activity to lightning strikes and meteorite impacts, the researchers found themselves confronted with an extraordinary possibility. The molecule might be a byproduct of living organisms inhabiting Venus, mirroring the microbial life that graces our own planet. A particular layer in Venus's atmosphere, situated 50 to 60 kilometers above the surface, has conditions surprisingly akin to those on Earth. The pressure mirrors that of sea level, and temperatures fluctuate between 0 and 50 degrees Celsius. Even with the daunting sulfuric acid clouds, organisms on Earth have displayed a capacity to endure similar acidic conditions, precisely where scientists identified phosphine. This isn't the first instance where Venus has beckoned astrobiologists with the prospect of life. In the 1960s, the peculiar behavior of Venus's clouds, absorbing more of the sun's ultraviolet light than expected, prompted speculation about potential photosynthetic organisms in the atmosphere. Recent evidence of Venus's geological activity further fuels the hypothesis that it might have hosted a habitable environment for billions of years. Venus's atmosphere is about 50 times more arid than the driest place on Earth, and its cloud layer is primarily sulfuric acid, with a mere trace of water. While some earthly microbes endure highly acidic conditions, none exclusively exist in the air throughout their life cycle. The Venusian challenges are formidable, requiring life to find a surface at some point in its cycle. The potential for life on Venus remains uncertain, but profoundly intriguing. Scientists are determined and excited to keep studying this mysterious planet, even though there are challenges. They hope that by exploring more, they might find signs of life beyond Earth in the cosmic dance of discovery.